Welcome to Zaption 5.1, Rate of Change and Slope. Here is the essential understanding. You can use ratios to show a relationship between changing quantities. Now don't forget, a ratio is, like A to B type of thing. That's what a ratio is. And the first thing that we want to talk about is make sure we have a definition down for the rate of change, the title of the Zaption Tour. The rate of change is defined as the change in the dependent variable divided by the change in the independent variable. So notice that this ratio thing, it's right there. It's the change of the dependent divided by the change in the independent. Okay, box number 1 is an example. It says find the rate of a change using a table. So I have time in minutes and I have distance in feet. And this is the distance that a marching band marches in a minute, okay? So what we want to do is remember the definition for rate of change. It is the change in the dependent variable divided by the change in the independent variable. This little triangle thing here means change in, it comes from physics, the delta. Okay, so which one's the dependent variable? Does the distance depend on the time, or does time depend on the distance? Well, you should realize that the distance depends on the time, so distance is the dependent variable. So what we want to do is we want to figure out the change from 1 minute to 2 minutes. So from 1 minute to 2 minutes, we take 520 and subtract off 260, and we get 260. Okay? Now from 2 minutes to 3 minutes, again, we would take 780 and subtract off 520 and get 260 again. And then and between 3 minutes and 4 minutes, we would take 10,000 or 1,040 and subtract off 780 and again get 260. So for equal units or equal measures of time, minutes, right, we're seeing that we have a constant rate of 260. So therefore the rate of change is 260 over 1. And what that means is that means that they go 260 feet for every 1 minute. That's how we do it. So the reason that there's a 1 in the bottom here is because the change in my independent variable is 1 each time. That's why that's down there. Box 2 is a relationship between rate of change and the slope of a line. Hopefully you realize that these two things are exactly the same thing. Okay, rate of change is the change in dependent variable over the change in the independent variable, and the slope of a line is just the vertical change over the horizontal change. So rate of change and slope are the same exact thing, and they are defined the same exact way. Okay, so you might know vertical change as something called the rise, and you might remember horizontal change as something called the run in your previous pre-algebra classes, and this is what we're going to explore. Box 3 is an example. It says find the slope of the lines using a graph. Okay, so each one of these represents a line that goes on forever and ever. All right, and I've got graph A and I have graph B. So we want to figure out the slope of the line. So we want to figure out the rise, and then we want to figure out the run. So pick a point that you can find anywhere on the graph. I can clearly see that that point is on the graph. That's 0, 0. And I can also clearly see that this point over here is on the graph. Okay, that is 6, 4. And I could have also picked this one. You should notice that it's going to be the same thing no matter what. Okay, so I want to calculate the rise. The rise is how far up I need to go to get even with that second point. This is what's considered the rise. Okay, so the reason I know that this is a rise is because when I go left to right, the graph goes up. So therefore it's going to be a positive slope. Now let's calculate the run. The run is how far over what I need to go to get from here to here. Well, you can see that that distance is exactly the same as that, which is exactly 3 units. So this is called the run. Okay, so the rise is the vertical distance, the run is the horizontal distance, and the slope, okay, of this line is considered the rise over the run. Notice that it is indeed a ratio, rise over run. In this case, the rise is a value of 2 units, and the run is a value of 3 units. So therefore, our slope is going to be a value of 2/3. In part B, let's pick a point. This point is on the graph, and this point is on the graph. So let's talk about the rise. Well, in this case, I don't need to go up. I have to go down to get even to my second point. So I would go down this much. This is going to be my rise. But in this case, because I'm going down, it's going to be a negative. So this is worth negative 3 units. So down 1, down 2, down 3. And then I want to figure out the run. So that would be how far this way do I go? Well, that would be 1, 2, 3, 4, 5 units. So this would be my run, and this would be 5 units. So therefore, the slope of this line would be the ratio of the rise to the run. Rise to run. Therefore, the slope, of course, is negative 3/5. Box number 4 is a you try. I've given you 2 points that are guaranteed to be on this line. What is the slope? Be sure you simplify your ratio. Hopefully you got the right answer. The rise is a negative 16 because I'm going down from left to right, and the run is 10 units. So therefore the slope is going to be the ratio of rise to run, which in this case is negative 16 to 10, which is negative 8 to 5. So we always want to make sure that we simplify our ratios. Now also notice that negative 8 to 5, if I had gone down negative 8, and then gone over 5 units exactly, I would have that same ratio there. So it does make sense to have it as negative 8/5. Box 5 is all about the slope formula, as where the slope formula comes from. So let's do this. Let's put a generic point on the graph. Okay, I'll put this point on the graph. I'll call this point A. And then let's put another point on the graph. I'll call this point B. So I'm going to pretend right now that I don't actually know the coordinates of these. So I'm going to call the point A at some x location 1 and some y location 1. Okay? And then I'm going to call point B my second x location 2 and my second y location 2, right? So I'm not sure where these are, but they're somewhere in the coordinate plane, so they're going to have an x and a y coordinate point. And I am interested in calculating the slope of the line that goes through each of these points. Well, because the slope of the line is always the rise to the run, as defined before, we figure out, okay, how far is it from here to here, right? What is that distance? Well, I can't look on the axis because I don't know exactly what that x value is, but I do know that it would have to be the value of y sub 2 subtracted from the value of y sub 1, right? Because after all, this value right here gives me y sub 2, and this value right here gives me y sub 1. So the difference of the two would have to give me that much right there, and that is worth the rise. So we're going to write that part down. So the slope formula, if I start with rise over run, it's equal to y2 minus y1. That's where that comes from. So this distance here is y2 minus y1. Okay, now let's figure out the run. Works exactly the same way. How far is it from here to here? Well, I don't know because I can't look at the x-axis right now, but I do know that this, if I look down, this is the value of x2, and if I look down into here, this is the value of x1. So the distance is the value of x2 minus x1. x2 minus x1, and there you go. Now we have a slope formula. So the slope formula can always be calculated as y2 minus y1 over x2 minus x1. Box number 6 is an example. Let's find the slope between 1, 3, and 4, negative 1, and then we'll use the picture to verify it. So the slope formula that we just figured out in box number 5 is equal to y2 minus y1 over x2 minus x1. Okay, so which one of these numbers represents y2? Remember, this is an x, and this is a y, and this is an x, and this is a y. So I'll call these ones 1, and I'll call these 2. Okay, so the value of y sub 2 is negative 1. The value of y sub 1 is 3. On the bottom, the value of x sub 2 is 4, and the value of x sub 1 is 1. So I have everything I need. So negative 1 minus 3 is negative 4. 4 minus 1 is 3. So therefore, the slope of the line should be negative 4/3. Let's verify that using the picture, okay? So let's put both of these points on the graph. Here's 1, 3. and here is 4, -1. 4, -1 is here, okay? And this slope would be a negative slope because I'm going down from left to right, okay? The value to get from here to here is a value of 4 units, 1, 2, 3, 4, and the value to get from here to here is a value of 3 units, 1, 2, 3. So yep, the slope is indeed -4/3. Box number 7 is all about slopes of vertical and horizontal lines. So let's take a look at this vertical line. It's the red line that I have here, okay? The slope of a vertical line is undefined. Okay, and the reason it is undefined is because consider these 2 points right here, okay? This would be the point 4, 4, and this would be the point 4, 1. Well, if I do y2 minus y1 over x2 minus x1, here's what I would get. Let's call this x1 and y1 and call this x2 and y2. The value of y2 would be 4, subtracted from 1, all divided by the value of x2 is 4, and the value of x1 is also 4. So look what I would get. I would get 3 divided by 0. So ladies and gentlemen, we can never have a 0 in a fraction. That's why every single vertical line has an undefined slope. Now, in blue, okay, the slope of this line is 0. Okay, the slope of this line is equal to 0. Okay, because there is no vertical change. It's 0, so it's 0 divided by some distance, which we'll call x, which will always just be 0. All right, so the slope of a horizontal line is always 0. Okay, last box. Did you try find, or what is the slope of the line through the points 4, -3, and 4, 2? You can either use the slope formula or you can graph it and see. Okay, hopefully you got undefined because this is a vertical line, and the slope formula will tell me the same thing. Check it out. If I do y sub 2, I get 2 minus -3, all divided by 4 minus 4. That would give me 2 plus 3 over 0. That would give me 5 over 0, and that would give me undefined. Okay, so I have a vertical line, and therefore the slope of this vertical line is undefined.